Students, it's the turn for the next segment of your question paper where we have 2-marker questions. And if I talk about the first question of this segment, that is question number 21. State Raoult's law for a solution containing volatile components. What is the similarity between Raoult's law and Henry's law? This question has 2 parts. In the first part, you need to write the statement of Raoult's law. While in the second part, you need to just compare Raoult's law with Henry's law. Let's check how do we solve this question. So first of all, you need to write the statement of the Raoult's law as I've already told you. So here we'll mention that Raoult's law for a solution of volatile liquids, the partial vapor pressure of each component in the solution is directly proportional to its mole fraction present in the solution. It means the solution you have in which volatile liquids are present, and in that case the vapor pressure of particular component is directly proportional to its mole fraction, and after this is the mathematical statement for this. Pi is equals to Pi naught Xi. This Pi naught is basically vapor pressure of the pure component, while Xi is the mole fraction of the component I in the solution. So this is the representation for Raoult's law, its statement, mathematical expression for the statement it is, and if you are writing the statement correctly, you will get 1 mark. Similarly, you need to just write there the next part, that what is the similarity between Raoult's law and Henry's law. We generally say Raoult's law is a special case of Henry's law. What is the statement of the Henry's law? We represent P is equals to KH chi or X, that is mole fraction basically. So KH is the Henry's law constant. While if I talk about Raoult's law, the statement is written here. We need to just represent the similarity there. We can simply write the similarity by quoting that Raoult's law is a special case of Henry's law in which KH becomes equal to Pi naught. What is that Pi naught? That is the partial vapor pressure of the pure volatile component I or gas. I hope it is clear. So 1 mark for the writing the statement and the 1 mark for comparing Raoult's law with the Henry's law. And while doing so, you will get the complete 2 mark for this question. The turn is there for the next question. Now here's the question number 22. Write the role of dilute NaCN in the extraction of gold. First part will give you 1 mark. CO in the extraction of iron. The second part, this is also going to give you 1 mark. This question has internal choice. So we are considering here the first option that you can do here. What will be the answer for the first part? Let's have a look on that. If I talk about dilute NaCN, it has an important role in the extraction of gold because it combines with gold in the presence of oxygen to form a complex, right? So we can simply say that in the extraction of gold, the role of dilute solution of NaCN in the presence of air. What's the role of air here? Air is providing oxygen. Basically, it is there to dissolve the gold and formation of a complex of gold. This can be represented with the help of the chemical reaction where gold is there reacting with NaCN, H2O and O2, and there is the formation of the gold complex. I hope it is clear, and this part will give you 1 mark if you are attempting in this manner. Let's take the next part. CO in the extraction of iron. Carbon monoxide, a very good reducing agent, and in the blast furnace it is used in the reduction process. So simply you can write the role of CO in the extraction of iron is to reduce the concentrated hematite. What is that? Fe2O3. That is the ore of iron, and it is reduced in reduction zone of blast furnace. That can be represented by the chemical equations which are written here. Fe2O3 is reduced by carbon monoxide. First of all, Fe3O4 is formed. Then this Fe3O4 further gets changed into FeO, and there is finally the formation of iron. Molten form you will obtain. I hope it is clear. And yes, this part will give you another 1 mark. So 2 mark you can obtain by writing the answer of each of these parts. Further, if you are not choosing this option, you can choose the second option here. How is leaching carried out in the case of low-grade copper ores. Further, name the method used for refining of copper metal. Basically, for the refining of the copper metal, we use the method of electrolytic refining. And what would be the answer of first part, where leaching method is given for the extraction of copper from low-grade copper ores? You can simply write the answer for this particular question, that copper metal is extracted by leaching process from low-grade copper ore. How? It is leached by using acid or bacteria. The solution containing Cu2 plus ion there, and these are treated with scrap iron or hydrogen. That can be represented with the help of chemical equation that's clearly given here. You can clearly see Cu2 plus ions are there, reduced to give you copper metal, right? So this is the part which will give you 1 mark. So I'll just mark here that 1 mark you will obtain if you are mentioning the leaching method for the extraction of copper from the low grade ores. Further, the next part was there, which method you prefer for refining of copper. Simply you can say crude copper metal is refined by electrolytic method, where pure copper is used as cathode while impure copper is used as anode. Basically, this process is done in the electrolytic solution of the copper sulfate. This is acidified copper sulfate solution that is working as the electrolyte. So in this case, you need to just write the name of the method. So simply writing electrolytic method will give you 1 mark. So 1 mark you will obtain here. Total of the 2 marks you can obtain by attempting this part also. So this was question number 22. Turn is there for the question number 23. Let's take question number 23. Define adsorption with an example. What is the role of adsorption in heterogeneous catalysis? Basically, this is the question where you need to write once again the 2 part. First part, to write the definition of adsorption with example, and the second part, the role of adsorption in heterogeneous catalysis. Basically, you can simply answer this question by writing that adsorption is the process where a phase is adsorbed over the surface of another phase. So we can simply write the answer that accumulation of molecular species of one phase at the surface of another species rather than in the bulk of that particular species, whether it is solid or liquid, and this process is termed as adsorption. So adsorption is basically the surface phenomenon, right? What would be the example? The example you can write here. Gas mask. What happens here? In case of gas mask, there is the gases which get adsorbed on activated charcoal. This can be the example. Further, next part is what is the role of adsorption in heterogeneous catalysis. So simply you can answer heterogeneous catalysis involves the different phase of the catalyst as compared to the phase of the reactant or the product. So the role of adsorption in the heterogeneous catalysis is that the adsorption of reactants on the solid surface of the catalyst increases the rate of reaction by making another activated complex, and that is basically lower the activation energy. So this is the path where lower activation energy is there. So this is basically the role of adsorption here. I hope it is clear. So this question will give you 2 marks if you do in the similar manner. Now, in the similar question, there is internal choice also, and what it states, define Brownian motion. Another question from the surface chemistry. What is the cause of Brownian movement in the colloidal particles? How is it responsible for the stability of colloidal sole? So this question can be answered first of all by writing the definition of Brownian movement. What is that? The colloidal particles appears to be in a state of continuous zigzag motion. Have you ever seen this zigzag motion? This is the motion in which colloidal particles are continuously moving. This motion is called Brownian motion because this was first observed by Robert Brown. Now, the next part, what is the cause of the Brownian movement in colloidal particles? You can simply mention that Brownian movement has been explained to be due to the unbalanced bombardment of the particles by the molecules of dispersion medium. So this is unbalanced bombardment of colloidal particles. 2 parts we have done. The next part is asking you to write how is it responsible for the stability of the colloidal sol. What is the role of the Brownian motion in case of stability of the sol? You can simply write the reason that Brownian movement has a stirring effect which does not permit the particles to settle. And if particles are not settled, it means colloid is stable. So very simple, that's why it is responsible for the stability of the sol. So 1 mark you will get while writing the definition of the Brownian motion, half mark for writing the reason for that, and half mark for writing role of the Brownian movement in stability of the sol. And definitely this question will provide you 2 marks overall if you are writing all the steps. I hope it is clear. So till now we have done question number 23. Turn is there for question number 24.